Good evening and welcome to another episode of Bar Arduino Worldwide. I'm here with my friend.
Oh, Benedetta.
There was some strange thing that happened because the screen froze exactly the moment we started speaking. So
I thought it was on purpose, so I got confused.
You thought I was playing a trick on you.
I did.
No, my pranks are better than this. Come on.
You are very well known for your tricks. So.
Yeah. So we're not going to have any funny intro today because the world is a little bit too crazy right now. So we're just going to
go straight in.
Just go directly to business. And so, Benny, is there something you want to remind the audience?
Yeah. Do I do my job, my usual mom job? My usual mom job is to remind everybody, especially if people aren't watching live, but also if you are watching live, to take advantage of the comment section and add either questions for the guests that we have or questions you might have about the project, but also just send us any suggestions for things that you would like to see in the next few weeks. And we'll, do our best to incorporate those things into next week's episode. Did I do a good job?
Yeah, no, that was great. I was actually writing your grade now on a little piece of paper.
Thank you.
For your evaluation.
Like things that you lift up with like the number.
Yeah, no. It just at the end of the season.
I want all 10.
At the end of the season, you get a feedback package that says, how you.
Oh my God! Do I get a course evaluation like I do?
Absolutely. I mean, you're basically an intern right now, so sorry. This is a bad joke.
A lot of scaling up to do.
No. And so normally, if this was a chat show on a late night show in the US, we would say that we have great guests, but it's true. We have great guests tonight, really amazing. So I don't want to really take a lot of time from them. The only thing I wanted to say is that we have a discount code as usual, and the usual discount code is related to one of the guests. And tonight the discount code is Brooklyn,
which is actually where me and all of the guests work.
So this episode, the guests are all friends of Benedetta.
Yeah.
This is
my show today.
It's the advantage of working in an amazing place, no?
Yes,
that you are surrounded by amazing people, no?
Yeah.
And I am by myself in this office. So sometimes I talk to this Bluetooth speaker that's shaped like a mushroom, and that's about it. But apart from that, so why don't we jump right to the first guest, and I leave it to you to do the talking.
Okay. Yes. Am I going to bring her in?
I can bring her in.
Okay. So yes. I wanted to introduce Kayla. I'm not even going to try. You're going to say your last name after because I destroyed it 2 times on the show already. So it's
the guest has to unmute. The only thing I'm just doing the.
Yep. Okay. So Kayla is a professor at NYU, and she teaches human-computer interactions and learning sciences. She does really amazing research projects and teaching around really empowering students and giving students access to technologies that normally might actually have kind of left them out or that they've been marginalized by. And I'm going to stop right there because I don't want to butcher it. But so Kayla, thank you.
You did a great job. And DesPortes is how you say my last name. So let me go ahead and just share
some images for us.
Yeah. Share the screen, and I will bring it to the live.
Right. Can you see it?
Awesome.
Okay. Yeah. So as Benedetta said, I work in this kind of really cool space, like thinking about the Arduino and physical computing kind of more broadly. and how do we design educational spaces. And I've worked in kind of this ed tech with artistic computing for about 7 years, so I'll share some of the work and insights and projects that we're kind of right in the middle of throughout this. But I think this is the standard first question: what was your first project? So my background's in electrical computer engineering, and the first thing that I ever built was called the Flexicopter. I'm really proud of the name more than anything else. But it was this basically flex sensors embedded in this glove that could control this RC helicopter. But it was kind of funny because it sounds cool, but actually the flex sensors are really crappy interface for controlling an RC helicopter. So we integrated a gyroscope so you could kind of like twist your wrist and move your hand up and down, and it would control this. And I got to work on it with some really close friends, Zach and Jaya. So that was my first kind of like integration into physical computing, and it was super cool. And then when I graduated, I went and worked in the tech industry for a couple of years, and it became really clear how little diversity there was. And so I started getting interested in like, why are these, why do we have this lack of participation across different genders, races, and that kind of thing. And one of the many things that you can do to improve diversity is try and create more diverse learning experiences. And so I've been engaged in this question for many years now. And I started collaborating with artists, which have led to these really amazing experiences that give students kind of this medium of expression that integrates computer science and electronics along with all these other artistic disciplines. And so kind of my first explorations into this was a project called the Move Lab, where we worked with students on dance and choreography, and the Day of the Dead project, where they built interactive puppets. So just to give you kind of like an idea of what students are building in these, the students in the Move Lab created 3 dances. One was on deforestation and nature, a second was on bullying and how to stand up to your bully, and a third one was on how do you build your self-esteem. And there was different ways that they integrated tech into their projects so that it kind of could be expressive of how they felt about these issues. And then the second project, to kind of give you another perspective and a video, and I'm not sure, Massimo, if you need to play the video for this or switch up. But
what this does is that we have a flex thing right here. So as you see, it's not matte now, but people tend to actually bend their tablet or any other device. So basically, this shows like your range of it. So when you bend it, it goes like that.
Okay, cool. So yeah, so that was kind of one example of the types of things students are making, and this was done in a project called the Day of the Dead project, or Dia de los Muertos, where students reflected on the holiday and on their own cultural practices of death and mourning and loss, and then created these interactive puppets. And some people created around things that they lost, or people that they've lost in their life, as well as objects, like this young woman who built it around a tablet that she was really angry because she couldn't watch Netflix. And so there's lots of challenges in this space when you think of an educational perspective. Like, how do you help students be creative in terms of the technology, but also how they're thinking about the technology dynamically to be expressive? And then how are you helping them learn about the artistic disciplines as well as all the computing stuff? And you have issues around time, and how difficult it is for novices when they're working with all this stuff for the first time. How do you help them debug their issues? And then how do you also help them work with kind of the materiality of the electronics integrating into things like wearables and these puppets. And so kind of my first exploration into the tools to work with Arduino was around how do we think about redesigning the breadboard. And this was one of those things that just came out because I was really frustrated in these kind of short learning experiences having to explain the breadboard a billion times. So I created these kind of little modular breadboards, which is still a breadboard, but it brings a little bit more visibility to where the connections are. So you can see there's one connection block. So everything in that block is electrically connected. And that's a little module that has 2 electrically connected patches. And then here's just an example of how you could connect 2 kind of LEDs in series using that orange block. So I made this, and we started testing it with students. And it was really cool to see how their collaborative practices changed when they were using these, because it would spread out the circuit. I didn't have to explain it a billion times. I had to explain it a couple times still. But so that was kind of a win. But there's also some drawbacks, right? Because now they had all these other little things that they're playing with. And so that's like one of those things when you're playing in this design space, there are things that start to improve and other things that might kind of go backwards or counter to what you're experiencing. And then I started to think, like, how do we push kind of this idea of visibility? So if we were bringing visibility to where connections are there ways that we could also bring visibility to things that are typically invisible? And so here you can see there's that, I call it a voltage module, where it's basically continuously reading the voltage across two breadboard connections. And these are just in the prototype stages, but we're also thinking through, like, well, what if you could also visualize current in the wires? And is there a form factor that you can create to help do this? And then what does that mean, not only for what they're learning about it, but then when they're working with physical computing projects, can they debug their code and electronics more easily, getting insight into these things? And so then I took a step back and I was thinking, okay, well, those are prototyping tools, but what about circuit modules? And like kind of the question when you're in these spaces is always like, what do you black box and kind of just make plug and play? And what do you kind of give them insight into so they're learning so they can kind of like gain proficiencies and kind of like progress? And so I started to think about these circuit modules, which is like, can you black box some things, but not everything? And so you can see that this is an LED resistor circuit where the resistor now is like, you can manipulate it, right? So those are two pin headers and you can like flip it in and out. And so instead of having to teach like a breadboard or the bit blocks before you get to this concept, you can get to it really quickly. And then you could also talk about outputs with an Arduino really quickly. But then you can think about designing these boards for learning about specific things, right? So this is a board that's a pull up and pull down resistor with a 2-prong sensor. And so you can flip out things like a light sensitive resistor, a thermistor, and then also play with this idea of data and how is it showing up in the code and how can you like invert your signal and what does that mean? And those are kind of these really deep concepts that you can get to relatively quickly when you're using these boards. And so Massimo, if you want to play the second video. So you can imagine that you're kind of like going through this process and you're trying to figure out, okay, well, how do you design these boards? But then also, how do you design the activities so they're actually thinking about the concepts that you hope you're thinking about? And we're still in the process of kind of building those out and testing them. But this other thing that kind of like jumps back to like, okay, but we're in these artistic disciplines, right? And so what does it mean for the tools to be integrated into, let's say, an interactive mural? And so when we're thinking across these, what's become really important is how do you help students kind of iterate on their ideas? And so like if you're thinking it would be really powerful for an LED to be like blinking really fast at you, but then later you decide, actually, I would rather have sound and get rid of the LED. If you've already designed everything and soldered it together, it's really hard to change. On top of that, with the timing constraints, you don't always get to being able to solder. So how can we create these semi-permanent solutions? And so this is my Stackable Arduino. I'm not the first person to do this, but this is the one I created, and this is a Pro Micro in there. And then we create all these other like secondary boards to fit into this system. And if we think through kind of the ideas in the circuit modules, and even the ideas in like bringing like a voltmeter into these boards, we can kind of expand on the ways that they can get integrated into these artistic practices. And so this is just an example of potentiometer changing neopixels. And then we're currently in the process of working on designing these live interactive murals using this system with a group of about 15 high school students. And so it's done with this group called Community Word Project, who's super awesome and has done arts education for, I think, over a decade now. And they're looking to how do we integrate kind of computing into the things that they already know how to do really well. And so they're really good at getting students to, or teaching students the literary art of poetry. And this is the students kind of messing with their lines of poetry on these pieces of paper. And so they come up with these lines of poetry, or sorry, they come up with these poems, and then they take a couple lines and design a mural around it. And so this is one example. Like I said, it's in progress, but these times don't last. Unify our spirit, soul, and mind. And one idea that they had is that this like peace flag will be a lever, and as you raise it, then you kind of turn on the warmth that's within this house. And they're thinking of like lights within the house, but then sounds, and they're also talking about smells. And so like, it's this idea of putting this affective dimension into what they're thinking and how they're making decisions about the technology, which I think is really cool and powerful. And this is also part of Benny's work. She's a collaborator on the project with me. And then the last project that I'm going to just quickly touch on is we're also working with this group called STEM from Dance that works on getting young women of color working with dance and physical computing. And we're collaborating with them on a project sponsored by the NSF on how do we get students to start to learn about machine learning with wearables for dance and create kind of like, if you can detect certain poses, can you then have the LEDs light up in certain ways? Or if you can do something with the accelerometers, then you can create these other cool outputs. And then also like thinking across the materiality, so that the snap circuits for the interactive murals works really well for that project, but it's kind of too big and too hard for wearables. So how do we play with kind of like the soft and the hard pieces of these electronic materials when they're working with the Arduino? And yeah, that's all I had.
Awesome. Thank you so much. Thank you, thank you, thank you. All these projects are just really amazing. And now that you're thinking about the like visualizing the invisible, which I think it's super powerful when it comes down to like learning electronics, because so much of it is about kind of uncovering and like looking under, you know, the inside the box and trying to really understand how things work. But you do get to a place where you can't visualize it and you just kind of are, you know, we've had this conversation in teaching together where I just have tried my best to explain certain concepts to them. But thinking about the actual having these displays or having these modules kind of tell you more, especially if you think about the context of like the flipped classroom where like maybe you won't have a chance to do as much hands-on troubleshooting as we did in the past. Those would be super useful to kind of guide the students through. So
yeah, definitely. And like, I think there's this like other question too. It's like when something's visible, it creates conversations in the learning environment. So it's like, what kind of things do you think they'll start to talk about? Will they even like understand what it means to have like 3.2 and then it changes to 2.4? Like, what does that mean to somebody who's new at this stuff? So I think there's a lot of interesting questions as to like, when we actually start testing it out, what's going to come out of it.
And plus people will see like, you know, things like consumption, even if it's just like a tiny LED, but maybe on like a grander scheme, sort of, it will make them rethink how they use components and how they use resources. And that's super cool. And having participated with Kayla and we work with these amazing young adults, high school students who are really super talented. The day that Kayla whipped out the snap circuits, it was really amazing. It was really, I think, a super successful way to introduce them and in a way cut some corners in terms of timing without actually cutting corners, like without actually, you know, depriving them of any sort of lesson. I think that was, you know, I think what you've been looking at is really interesting to find the spaces where you can kind of optimize or make it easier, make it more accessible without taking away from the experience. So those were really, really cool. How's the dance project? What can you tell us more about this intersection? I don't think people necessarily put together machine learning and dance and physical computing all in the same place.
Yeah. So currently we're doing a lot of online stuff with the Teachable Machine from Google. And we're creating some interfaces to help students create overlays onto their dance videos. So like, let's say you put your hand up, and then when you put your hand up in your dance, every time you want a firework to happen in that like other corner. And so, and that's all through processing. But the really cool thing about processing is like it has that serial connection, so you can start to talk to physical computing things. And so we're looking at like, okay, so if we can start to send signals now when you recognize certain poses, are you going to send some information to the wearables that you have? And then can you also start to look at incorporating other data besides just the visuals into your machine learning model, like the accelerometer or the gyroscope or these other things, and what does it mean to play with that instead of just like the way we like conditionals that we already know how to integrate into these spaces. And so it's still like pretty much in its infancy, but we're coming up with some super cool technology this summer that we're running in an online environment, and yeah, it should be fun.
Awesome. I look forward to playing with that. And I think there's some Arduino boards that have so much stuff on them now. They have so many different sensors that
Yes.
would be a really cool.
We have to send you one of these.
Yep.
I'm in.
It's got a ton of sensors and be a Bluetooth low energy. It's perfect for this kind of project. It's got gestures, accelerometer, gyroscope, magnetometer, microphone, temperature, humidity, distance, color sensor. Ooh.
Yep.
So we will send you one.
Yeah.
Thing to plug in.
So there's a number of comments on the chat that people love your work, which is really great. There's some people who were very excited, which is always nice. And also, yeah. Somebody asked if you ever met the people at Lil Bits.
I have not. It's kind of funny because where I got my graduate degree is also where one of the like main founders came from. I haven't worked with them yet. I think there's a lot of really interesting connects because of how they're in the education space, and they do a lot with these like modularity of how you design these things. I think it's from the designs, it seems like we prioritize a little bit of different things. Like mine prioritizes kind of the education, whereas they prioritize like how do you create things really quickly. And both of those things are kind of valid in different contexts. But yeah, I'd love to work with them. That'd be awesome.
Nice. Wow. I love the project. I was very interested in this idea of reimagining the breadboard because kind of the breadboard has been the same thing for a very long time.
Yeah.
And
it takes forever to explain in a way that it makes no sense. You explain it and then you're showing it, and you're ripping the back off, and you're like, these are connected this way, but these are not, and these two things aren't either. It's like a super confusing lesson.
Yeah. No, like I said, like that was like purely built, like I was just super frustrated. And I was like, there has to be some design we can like get through this.
Yeah, which is also the place where some great ideas come out of this, personal frustration towards something.
Yeah.
In a way, Arduino was born out of kind of the frustration of some of the development environments we had back in the days.
Yeah, definitely.
Nice. So do you, so I guess because of the COVID, everybody was kind of locked in. Did you do any kind of online classes, or were you doing some kind of online training? Because, I'm asking because teaching physical things online is kind of a challenge. So I'm asking people who do that. How was your experience?
Yeah, so I'm in the education department at my school. So I was teaching design process for learning. So it wasn't teaching physical computing, but we're designing. And I think you guys had Kit McDermott on here the other day. Yeah. So she's actually working on the dance project with us. And we're thinking through, because we're doing basically one is like a teachable machine with P5, but we're also doing basically Arduino with just kind of like inputs and outputs without the machine learning to start. And so we're developing like, how do we get tutorials for sewing? And I think she's already started to get some of those together, but then we haven't yet put out content, but we will. But yeah, so we're thinking through it.
Yeah, and with the community work project students, we had a physical component and a digital component, and so we kind of resumed with the digital piece now, and we changed a few things around, and we introduced like stop motion animation and a few other things that you can do online, and are thinking about, you know, how to kind of create kits and or purchase kits or partner with people that make kits, so that we can bring back the physical computing element too. It just takes more planning, right? It's something that you have to kind of not just sort of roll in very last minute. It needs a little bit more thinking through in terms of logistics. But I think that's something that now we're kind of, for all the physical computing classes, thinking about kind of always having stuff at home. I think it's the one lesson we all learned. Half of my lab, it's still at the lab. And then online resources, right? The flipped classroom for physical computing isn't too hard. The troubleshooting is, which is why things like, you know, like making kind of those leaps and being able to visualize things, or just instead of having everybody having a multimeter at home, or, you know, being able to kind of really probe things correctly to even troubleshoot. That's the challenging part, I think, in doing this remote.
I totally forgot. I was teaching the VIP course online. We did do physical computing. I forgot. Oh yeah, we ended up doing like flipped classroom, where we would like find videos together, go through them, and then like the troubleshooting was the like, all right, share your screen now, show the video of it. Yeah, it was hard.
Nice.
But it is true. Like somebody said in the comment, it does make quarantine. It did make quarantine fun.
Yeah.
And much more bearable.
Yeah. Okay, so we're moving to the next segment, but you know, this was great. Thank you very much. Love the project, love the presentation, and you know, I love everything that's to do with education. So thank you for being here. So stay with us, and so we bring you back at the end of the last part of the show, so we can say goodbye to the audience. And there might be some other questions that pop up, so you can answer them later. So we will. So thank you very much for now. We'll see you in a few minutes.
Sounds good. Thanks, guys.
Thank you. Okay.
Yeah, and if people want to hear more about education.
Yeah, I also posted her website URL in the comments so that people can have a look at the project. And you know, it's just amazing work. I love that. Actually, one of the things that we should mention is that Arduino has an education-oriented show, which is called Arduino Edu Vision. You can find it on Facebook and YouTube at 4 p.m. on Thursday, 4 p.m. European time.
Oh.
4 p.m. European time, which will be something like 10 a.m. in your part of the world. And in California, it will be 7 a.m.
Early.
Well, you know, maybe people
are healthy. They wake up, they go running early in the morning.
It gets recorded. It's very nice because the education team, there are 3 lovely young women running the show, working the education department. Yeah, one of the things that we kind of never mentioned enough is that within Arduino, we are almost 50-50 men, women. So we do try to be, you know, so I'm very proud of that. And the work they're doing is amazing. So if you should check it out, you can find the videos on YouTube, recorded, or you can be live on Thursday at 4 p.m. European time. Also, it's a good moment to remind people that the discount code for this week is Brooklyn. Woo. And yeah, one of my favorite places in the world, Brooklyn.
Yep. One of the places where we drink.
Yes, where we drink. Where can I come back? Is it do you have any idea where can I come back in the US, or is just?
I think it will take you. I think it's the other way around. I don't think we're going to be allowed to go anywhere anytime soon.
Whoops. Okay.
You coming from, from Switzerland, I think.
Last Saturday in the morning was the first time I left Switzerland in 3.5 months to go back to Italy to see my mother, and then I came back. As a good Italian, I had to go, and
I'm very proud of you.
Thank you. So one of the nice things is that Arduino has a lot of very competent people, and the very competent people at Arduino have been working at putting together some short videos, telling you things you never knew about the Arduino platform. And here is one of our top engineers, Martino, talking about something that has to do with USB. Let's see the video.
Hello everyone, I suppose you all love USB. 20 years ago, it was extremely difficult to connect something to a computer without relying on this kind of cable, serial cable, parallel cables, PS2 cables for keyboard and mice. USB changed everything. So, did you know that you can turn your Arduino into any kind of USB device? Besides the most common devices, like a keyboard and mice, that are shipped with the IDE, so you may have already seen them, there are a couple of other very interesting libraries that you can turn your Arduino into. For example, using Web USB library, you can directly talk with a browser, a modern browser like Chrome, and interact with the web page. You can also turn your Arduino into a musical instrument using Midi USB library. There's plenty of devices which has not been ported as Arduino libraries, but the infrastructure is there, so it's only up to you to code them, try them, and share with the community. And enjoy the process in the meantime. Thank you.
All right, so there is an interesting question from the audience about why is it called bytes, and it was peels and shots.
Keep changing.
So, well, so it's interesting because sometimes some of the people who work on these things are Italians. So in Italian, it's common to call this thing called peels of knowledge. But, sometimes outside of Italy, the word peel is,
doesn't have that positive of a connotation.
And then shots, has to do with alcohol. And, sometimes people perceive that they don't. So first of all, it is a problem for me to explain that bar in Italian doesn't necessarily mean
That's true.
a dive bar when you have, alcohol. Because in Italy, bar is, Benedetta?
The cafe.
Exactly. It's just a cafe. And so it's called Bar Arduino because Arduino was kind of, the name comes from a cafe where I used to go when I was in Ivrea, that you have seen, Benedetta.
Yep.
And so we decided to call it bytes because it's simpler, because otherwise people see that it's associated with alcohol, it's associated with drugs. It's like, no. It's associated with knowledge. So byte
feeds your brain.
It sounds a little bit like, bytes as in kilobytes or megabytes.
Oh.
Boy, it is difficult to
That was
make.
deep.
It's hard to make everybody happy. So, the next segment is from our friend Ubi, who sent us a video demo explaining some interesting technique that you can develop using Arduino. So we're going to show this video, which is in 3 parts. And then, so let's jump right to it.
Hi, my name is Ubi de Feo, and I'm gonna show you how to filter analog sensor inputs, smooth their values, and send them over USB. We're gonna use an Arduino Nano 33 IoT, but we could very well use a 33BLE or a BLE Sense, or we could use any of the maker boards. We're gonna focus on picking up some input from analog sensors and turning it into an HID signal. HID stands for Human Interface Device. We want to take signal from a potentiometer. We take this signal and we turn it into a signal which is going to be sent over a device, which is going to be our Arduino board. And this device over USB or Bluetooth is going to send signals to a computer or some other host. We're going to use USB and create a human interface device. So this device could be a keyboard, a mouse, an assistive device for people with disabilities. It could be a joystick, or it could be a MIDI device. And we're going to control an OPZ, which is one of the most fun devices to work with, especially if, like me, you don't really know how to make music. Let's see how we can write this code. My setup is comprised of a text editor, and I'm going to use the CLI, but you may write this code inside the Arduino editor or in the Create editor online, and it's going to just work. I'm going to use a serial monitor. So the code that we're going to write is going to let us take this input value, filter it somehow, and spit it on the serial monitor. I create a buffer, which is a list of values, and I use a technique called first in, first out. And basically I fill in this buffer, which is made of 20 positions, with values that are cycle by cycle read from the analog input. So this is my buffer, and this variable is gonna tell us which sample we kicked in. And what we want to do, we want to take all these values and sum them together and divide them by the amount of captures that we made. So after we capture 5 cycles, we're gonna have 5 values, we're gonna divide it by 5 and average the value. What happens is that when you use analog device, the input can be jittery, and we want it to be a bit more smooth. So we take these values, we sum them together, and we divide them by the amount of samples. So when we start in setup, we initialize the serial. This code is already uploaded, and I'm going to show you what it does. So I will connect to this one, and I will reset my Arduino board. You can see the word setup, and then the values being read. In our loop, we don't just read the value from the analog port A1, we go through a filter analog value function, which I defined down here. It returns an integer, the averaged out values taken from the reading of the sensor. We take the input from the analog read, which is going to give us a number between 0 and 1023. The Maker family and the new Nano boards allow us to have a higher resolution, but as a default, to maintain some legacy with our older boards, it's going to use a 10-bit resolution, which gives us a value between 0 and 1023. You can use analog read resolution and pass it a number. In this case, for the SAMD based boards, we can use 12 bits, and it's going to give us a number between 0 and 4095. But we're not going to use this one, so let's remove it. We read this value. I'm printing this value out, as you can see in the serial monitor. Let's comment it out. And let's go to the nitty-gritty of the code. We are actually counting the amount of samples we take, and when our program starts, sample index is going to be 0. So this is going to be the first value sampled. So until this value is smaller than the amount of samples that we're going to take, which is 20, it's going to fill up the buffer. So it's going to start at position 0, then go to 1, then go to 2, because we increase the sample index. Once we have captured the first 20 samples, we are going to remove the first value, shift all the samples from the second to the last, and then we're going to capture the current analog value and put it at the end of our array. This is going to make sure that we achieve what we call the first in, first out value. So the first value captured gets shifted out as soon as a new one is captured at the end of the list. This gives us a very fluid stream of samples. And then we go through this list of 20 values. We take these values, we sum them together, and then in the end, if the sum is 0, we're just going to return 0. We don't want to start dividing 0 by something or vice versa. And then we calculate this filtered value, which is going to be the sum of all the samples divided by the amount of samples that we have. So if we had 20 values, it would be divided by 20. We're going to return this averaged out value, and we're going to store it into this variable. And then we're going to map the value returned by this variable, which is between 0 and 1023, into a number between 0 and 127. And if the last value that we mapped is different from the return value, we're gonna spit it out on the serial monitor. I want to go to my CLI, Arduino CLI, compile -u, which stands for upload, and it's going to upload to the board that I have set up in the sketch.json. It's going to compile the sketch and it's going to upload it. So now my serial monitor is ready to connect to my Arduino board, and let's see what happens here. Setup is happening. Let's try and move the potentiometer. It has actually changed. What we're going to do with this value, we're going to send it out to a Midi device. Let's look at the serial plotter in the classic Arduino IDE. Let's move the potentiometer. The values are smoothing out, they're not going abruptly to 0 or to another value. This is a very simple potentiometer that sends us a value between 0 and 127. In Midi, we can use this value to control something. So we're going to just import this library, then copy this function, which is a MIDI control change function. So what it does, basically, it takes a MIDI channel, a type of control, which is a number, and it takes the value that we want to change, and it creates a MIDI packet, which is a message sent over MIDI protocol, and it sends it. We want to send this control change to our attached MIDI device. Because we're using Midi, we don't really need this anymore. We're going to comment it out. We're going to send this control to our synthesizer. I have an application called Midi Monitor, which shows the Arduino Nano 33 IoT as a MIDI device, and it tells me that I'm receiving some signal. So I'm going to turn this knob, and it's going to tell me that it's a foot control. And let's see if we disconnect it from our computer and we plug it into the synthesizer. I'm going to use a USB-C to a micro USB, and as you can see, the OPZ is powering the MIDI controller. Let's see what happens when we go and create some sound. So I'm going to go with this sequence. Just created a MIDI controller to control the OPZ by using an Arduino and a potentiometer. You can use different kinds of analog circuits to give you a voltage output, and then you can factor in the values and send them over MIDI. That's pretty fun, isn't it? Thank you so much for following this guide, and we'll be publishing the code soon, so let us know in the comments if you enjoyed it and if you want more of this kind of content. Thank you, and bye from Amsterdam.
That was super cool.
All right, so the URL here is points to the code for that tutorial. And I promise that in the next tutorial, we will use a font size which is actually bigger than 3 pixels so that people can actually follow in the video. But yeah, so that's the URL. So before we jump to the next guest, I just want to quickly bring something up. Let me just remove this. So first of all, we want to remind everybody that the discount code is Brooklyn. And one thing I wanted to remind people is that we launched a few weeks ago this competition called Touch Less, Do More. And so this is the URL. You can find it on Project Hub under contests. And yeah, it's just a competition to say, hey, in this post-COVID world, a lot of the things I used to do by touching and by being in contact with people, we can't do anymore. So propose some ideas around that. So if you want to have a look, there's quite some pretty good, very good prizes, especially some work that Avnet will. So Avnet contributed some work from Dragon Innovation to help people take their projects to products if they want to. So we are getting some interesting submissions yet still, and but the competition lasts for a few more weeks. All right. So now we have our second live guest.
Yes, which is a perfect, I think, segue from Ubi's.
Oh, Mr. Luc DuBois, you are muted. Please unmute.
Yes.
Hey, can you guys hear me?
Yeah.
Amazing. Cool.
Welcome, Duke.
How's it going?
Thank you for coming.
It's pretty good. Yeah, I mean,
thanks for having me.
personally pretty good. The rest of the world less, but hey.
In your black hole, you're doing fine.
Yeah, exactly.
Yeah. So yeah, no. Thanks for coming. So your projects are sound-based from sort of what I looked at some of the work that you do, and it was interesting that the tutorial had something to do with MIDI.
Mm-hmm.
So why don't you start off by telling us a little bit about you and what you do and
yeah. So I'm a composer and artist, and I do a lot of stuff. Not so much with hardware usually, but with software. So I worked for a long time on a software platform called MaxMSP.
Oh yeah.
And I create open source tools for artists to work with code. And this is my lab. So I work with Benedetta, and I work with Kayla and a bunch of people you've had on the show. And this is the audio lab at Integrated Digital Media at NYU Tandon. So you're in sort of a really funky recording studio with a bunch of weird machines in it.
Yeah, the audience is asking if that's a modular system over your shoulder.
That is a modular system over my shoulder, and I'm going to show it to you.
Boom.
And give you a quick tour. So what we do in here is we build new designs for modular synthesizers. So new open source designs for modular synthesizers. The synthesizers that we take as inspiration. I'm going to switch to my phone camera so you can sort of see what I'm doing. So is that sort of working?
Yeah.
Zoom around, great. So the system that we sort of take as an inspiration are synthesizers. So this is a modular synthesizer based on the designs of a guy named Serge Cherepnin, who developed a bunch of synthesizers at CalArts in California in the early 1970s. And if you know a little bit about the history of these machines, the sort of two big people like learn about or hear about first in the 1960s is a guy named Bob Moog, who was on the East Coast, and a guy named Don Buchla on the West Coast. And they made these systems that were very, very expensive. And so Serge's solution to make it affordable to hobbyists and students and amateurs was to make them DIY kits. So instead of spending tens of thousands of dollars to get a complete system, for hundreds of dollars, you would sort of order it and say which modules you wanted. And then he would mail you an etched circuit board, a Ziploc bag of passive electronic components and active electronic components, and a manual, and an aluminum plate and a sticker, and you would put it together yourself and solder it. right? And so if I sort of show you just something really simple on here, I'm going to move in a little bit. So this is an oscillator, right? And if you if I turn it up on the computer, I'm going to unplug this, we can just hear it. And there are jacks for inputs and outputs, and there are knobs to control things. And pretty much every parameter can also take control voltage. So I can make a melody by taking this orange wire out of this thing that's basically a sequencer. Does that kind of make sense? So the knobs are saying which pitch to play, and these lights are saying which one to do. Right? So I can program a melody with it. But every parameter can be controlled in different ways. So I can distort it, I could fade in another sound, right, et cetera, et cetera, et cetera. And they're kind of fun. But what's nice about them as from the Arduino perspective, these specific devices is you connect them with banana plugs. Banana plugs are kind of nice, not normal audio cables. So you can stack them, you can connect them. And they're all zero, they all take 0 to 5 volts with a common ground. Everything in the system. Sound, the control voltage, everything. So so what's nice about that is they're very easy, they're very Arduinable, if that's the word, right? You can integrate them into an Arduino system very simply. And so one of the things that last summer, once we sort of got this up and running, and this is all based on, I went to graduate school at Columbia, and at the Electronic Music Center at Columbia, they had the original versions of these from the 1970s. So that's what I learned on and worked on restoring. And so we've been sort of working on a bunch of them, restoring them, but then building new modules. And the thing we sort of realized is that modular synthesizers are an unusually, whatever you want to call it, hard to get into corner of the creative coding universe, right? So if you think about, if I want to become an artist who makes crazy generative things on websites, I can find books and videos and communities galore to help me. If I want to do something with physical computing and sensors and motors, you have your platform, you have tons of resources and whatever. Modular synthesizers, there tends to be a pretty small community of people who develop the circuits. A lot of the circuits are based on circuits from the 1960s and 70s. They have kind of, there's a little bit of a high bar of entry into that community if you want to be a designer. And that's actually a little bit ironic because since the late 1990s, there's been a standard platform or hardware standard for designing these things. It's called Eurorack. This company called Dopfer in Germany came up with it, but there's hundreds of manufacturers who use it. And one of the things that when you start learning about this, that you realize pretty quickly is that a lot of people get caught up on the concept of what does it mean for something to be analog. And the idea that there can be a lot of like kind of purism around that like analog sounds better, right? But the dirty little secret is as soon as you're talking about anything involving a control structure, like a clock or a sequence or something that stores memory or something that compares two signals, right? Or something that's a pulse, like a trigger for something, those are pretty much by definition digital systems. And so even in analog, quote unquote, analog circuits from the 1970s, you'll find things like 555 timers, right? And you'll find things like, kind of simple Texas Instrument, like comparator circuits, like LM393s or something like that. Those are all over the place in Moog and ARP and Surge equipment, because what they're doing is they're defining the logic states of things under the hood. And then the thing that it's coming to your ear is analog, but the control system is digital. So once you get okay with that, and once you understand that, then there's really no reason not to use a modern microcontroller for a bunch of this. And so if we move over here, I will show you the most ridiculous. So I should preface this with saying I'm really bad at Arduino. Benny is the only person Benny taught me everything I know. And so this, let me switch to.
We're going to zoom in a little bit on you. So we're still here.
Yeah, let me switch to my camera for a sec so you can see it. Do you see anything? Okay, so this is something called the shelficizer. And what it is is it's a totally ordinary rack shelf. So the kind of thing that you use to store USB cables, right? In a server room or something like that. I drilled a whole bunch of holes in the face of it, and inside is a bunch of Arduino equipment prototyped on breadboards. It's a mess, right? Total mess.
Ton of wires.
It's a ton of wires, right? So I didn't PCB it. I just left everything the way it is. So it's a rat's nest. And what all of these modules are is they're new inventions of my own that try to leverage the things an Arduino is good for, like saving state, doing like digital logic, taking analog signals in and making decisions based on them, and creating things that do sequencing. And so the guy on the left is just a really simple sequencer, and I have it wired up to a drum machine. So if I turn it up, you're just gonna hear a drum beat, okay? And that drum beat is programmed into the chip here. So I've got these little buttons that allow me to page around and change the pattern if I want. So I can like go through and like add more kick drums if I want or something like that, right? The module next to it does exactly the same thing, but instead of having a pre-programmed pattern, the blue jacks take voltage in and the red jacks put out pulses on a clock. And so what it is it's a comparator. So it's looking at the voltage coming in, and if the voltage is above 2.5 volts, when the clock arrives, it'll send out a trigger and fire the drum. Otherwise, it won't. And so what the result of that is you can create really interesting rhythms by basically sending in things like random voltages, or what they call in synthesis design, low frequency oscillators, so things that are fading in and out. And then the thing next to that is the same idea. It's an indexical sequencer. So you have voltage saying which of these 16 knobs I want to listen to. And if I turn that up, it'll make a crazy melody. That'll sound like a weird guitar solo, right? And if I turn it all up, you know, you've got this whole kind of crazy symphony happening based on all these systems. And you know, you can watch it. I've got some old oscilloscopes sort of showing you the music. But that's the basic idea. And I've been sort of building, you know, I've been building them for a couple years now, and they're really a lot of fun to work with. But the idea is eventually to have, you know, kind of a curriculum of sorts, so that anybody can build these. So we've been creating these boxes, this Analog Synth Club, right? Where you can have, you know, where you can have 4 inputs for affordances, so knobs, right? Like pots, switches, whatever you want, right? You have 4 jacks for your output. And then, you know, inside the whole thing is an Arduino 101. So you can use the built-in accelerometer on it as well. Does that make sense?
Yeah.
Yeah, and that's what we've been doing. I don't know.
That's amazing.
Yeah, it's fun, right? It's super fun. So
yeah, there's a ton of questions.
There's a lot of comments and a lot of questions.
People are asking, can you talk to other modules if it's 5 volts and the others are 12 volts?
Yeah.
So the internal logic is 5 volts. The power supply might be higher depending on the modules you're using. So I have one thing that's using a low part count sample and hold circuit. So like an LF398, that thing actually needs a 9 volt. That needs a higher supply than the logic you're working on. So again, with the Arduino chip, like a lot of times what I end up doing is, you know, like I might have to use a voltage regulator or something like that, so I can run the board on a separate thing. But the 5 volt standard is about the logic of the system. So the surge systems, surge modular systems are, you know, what are like just a lower voltage standard than a Euro rack. They're 0 to 5 volt. They're not, you know, they're not 0 to 12. You could upgrade everything pretty easily. Like the designs are really open, and you can do whatever you want. But the focus, or the intent of the project, is to get people playing really quickly with stuff, and you can plug these things through a format jumbler. So something like this. This is made by Low Gain Electronics in Wisconsin. This is just a passive format jumbler to go from banana to the 1/8" Eurorack standard, the 3.5 millimeter plug, with a common ground. So you can just use one of those, or you could just wire the whole thing to use 3.5 millimeter to begin with if you want. We haven't really gotten that far. I like the banana jacks mostly because in an educational institution, you want equipment that's fairly rugged. So one of the problems with actual audio connectors is it's very easy to break the jack, not the plug. If you use it really forcefully. So if you go to any university that has a Eurorack system, half the modules are broken after a couple years because somebody yanks the plug. Whereas in a banana system, the actual jack is just a metal cylinder, right? There's no way I can break this. If I'm going to break anything, I'm going to break the wire, right? And as dumb and superficial that is, as that sounds, that's a reason why it's a good reason to use these surge systems inside of a school. You're going to spend a lot less time repairing stuff. Yeah.
There's a few other questions, if I can. One is, how long have you been working on that?
Well, I started working on modular synthesizers in probably 1993, 1994. I worked at, like I said, at Columbia University, and they had an electronic music center. They have an electronic music center. It's the oldest electronic music center in the Western Hemisphere. It dates to the 1950s, here I'll share my screen for a second and show you something. Show you a silly photo. If I can do this, let me see if this will work. I share my entire screen. Yeah, so this, can you guys see that?
Yep.
Yeah, that's me. That's me probably at 19. That's a thing called a Buchla 100 series. So that was developed in 1965 in San Francisco by Don Buchla. But the other system that I worked on a lot was a thing called the RCA, which is a room-sized synthesizer from the 1950s. It was run with a paper tape drive, like a player piano. And the machine itself was so loud that you didn't use it in real-time operation. There was a shellac record lathe to the side, and it would cut you a record, and you would go into the next room and listen to it. Right. So that's kind of cool. That thing was pretty much obsolete within 5 years because some smart guy in New Jersey invented a thing called the transistor. So these are all solid state, right? The only thing in here that's dangerous is the oscilloscopes. The oscilloscopes are from the 60s and they're going to blow up and kill me soon. But,
There you go. You're getting a lot of nice comments.
I mean, but so like what, so there's a GitHub link to this thing.
We can
share
it in the chat.
Which I can throw into the chat, and you guys can share on the site. But eventually, it's gonna look like, I want it to look like a book or like a really rich website where it's like, okay, you want to make an analog synthesizer. Here are the simple patterns for how to make like a relaxation oscillator, which would be like the simplest circuit you would do to make like a sine wave or a square wave or a triangle wave. Here's how you make simple filters. Here's how you make simple amplifiers. All the amplifiers on this system are based on Vactrols. You know what those are? Like opto-isolation. So there's literally like a photocell duct taped around an LED. Right? And what's happening is the envelope, the thing that's letting the volume in, is lighting the LED, which is dropping the resistance on the photocell that the sound is going through. And that is a characteristic of analog synthesizers. And the sound of like the notes, the things that go pop, 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 that's literally like a light and a photocell married to one another, creating this thing. And so it's not that hard to do this stuff. And that's what I'm sort of working on.
Somebody was asking, what do you make in the end with all of these tools?
I make music.
I
make music. I make a song a day. I have a SoundCloud. I'm a SoundCloud person. So you can listen to the stuff on my SoundCloud. A lot of it is done with these synthesizers. Some of it's done with software I write, so it's digital. It's not analog. I also work on a non-modular analog synthesizer from the 70s called a Prophet 5 that has a keyboard, right? That kind of stuff. So there's a bunch of techniques and technology I use, but the main thing is that I think I'm a person who tends to make my own tools when I make my art. And I think there should be, there's no reason why everybody shouldn't be allowed to do that or have the ability to do that. And so I think that having systems like these, where even if you just want to understand what's inside of it, even if you're never going to build one to use, just knowing that you can and knowing how they work gives you some insight into them, which is kind of fun. I don't know.
Actually, I really like the modular synthesizer. I remember that when I started teaching, I used them a lot as a metaphor because you can actually get, you see the signal going through different phases, and you can see how each module is interacting with the signal.
Yeah.
And you can see that things like Max MSP are essentially that logic.
Yeah. I mean, Miller Puckett, who designed Max, right? The underlying design philosophy from a computer standpoint is it's named Max because it's based on the work of this guy Max Matthews, right? Who's sort of the godfather of computer music, did all the work at Bell Labs in the 1950s. But in terms of the design, it's a skeuomorph to these modular synthesizers, right? It's a bunch of boxes and you hook them up and it does stuff. So it's the exact same idea as these. And one of the things that's nice about Max as a platform is for people who come at code from like the engineering side, it's in a way sometimes a little bit more logical than writing C, right? It's more like learning a foreign language. You're like, oh, the metro object does this, the random object does this. I know how to connect it. It's very simple, right? But it's pretty fun.
Do you use pure data as well?
I use pure data a little bit. I've used pure data for embedded systems before. Yeah, like libpd, but mostly I use Max. I use Max and Max MSP and Jitter. Increasingly, there are platforms that support Max's Gen architecture. There's a subset of the Max language that can export to code, right? So it can export to C++, and then you can use that, or it can export to GLSL for like video shaders. The language is called Gen. And so there are a couple manufacturers now who make modular synthesizer units or guitar pedals that can take a Max patch as their code, right? So you can design something in Max and then turn it into a stomp box in your distortion algorithm, and you plug your guitar into it, right? And it's digital signal processing. It's not analog signal processing, but it's still a more equitable way. It's a way to lower the bar for kind of engaging with these products. It's easier to learn Max than it is to learn 56K Motorola assembler, right? Which is what most digital guitar pedals, that's what's in there, right? There's an FPGA and a DSP, right? And so that's not super easy for people to do. Yeah, but that's where I start from.
So I guess like the users are super excited about this stuff. So this is the best bar Arduino because you and Kayla kind of made the best presentations. And on this particular comment, we have to kind of go towards the end because I would love to keep chatting about this for hours, but we have a very precise producer that's going to start poking me. And Benedetta that we have to. So we put your GitHub, we put your SoundCloud. Anything else you want to plug?
Nah, just stay tuned. I'll be sending you more stuff.
I think people should definitely go and listen on. Anybody that's interested to find out what you come out with at the end.
Yeah. I will definitely send you guys everything.
So basically, the idea is that if somebody enrolls at IDM, they get to work with you and Benedetta.
Yeah, they get to hang out with all of
them. Well, actually.
And Kyle as well.
Yeah.
So if this is your favorite episode ever, the thing you have to do is to enroll in IDM. It's got a lot of great people in it, starting from Scott.
Yeah.
And, a lot of the people don't realize, for example, one of the most popular product ever made by Arduino, the Arduino starter kit, was written by Scott.
Yeah,
many years ago. 8 years ago.
The students occasionally find his name in the comments of the code examples, and then they flip out because the thing about being college professors is like I think like our students don't necessarily think that we're real people.
Yeah,
right?
we have our life outside.
Right, so they don't understand that, like, we might have meaningfully contributed to something that they might want to use. So so sometimes they'll find Scott's code and they'll be like, "Did you know that he wrote all this stuff?" I'm like, "Yeah,
yeah." Especially if you are like the director of something, they think that you're just a bean counter. So
yeah, for sure.
So let's bring back Kayla for a second, so that we can all kind of chat together. Yeah. So we were commenting on the fact that people don't think we are real people. So if you check some of the oldest examples written for Arduino, you will find even Clay Shirky.
Yep.
So Clay Shirky was writing Arduino code 10 years ago. So
good.
So thank you guys. So as I was mentioning, people have said that this was the best bar Arduino, and the person who reported that watched them all, apparently. So you will go down in history for the best guests.
And this is how lucky I am that I get to work with both of them.
Yeah, no, in fact,
we gotta make like a weird music thing.
I'm super cool.
We should make
we should make an album.
Yeah, we should make an album. Yeah, we should also make a curriculum or something like that. We could also make an album.
Yeah, we should.
Yeah, me and Tom Igo have a secret summer project, which also has to do with music and Arduino.
We don't know about that secret project.
I will probably bring back Tom before the end of the show, the season, just to talk about this tiny project we're doing. Yeah. So thank you very much, guys. If you want, you have like 30 seconds to just say hi or whatever. So let's start with Kayla.
No, this was awesome. I'm really excited that you guys tapped into me and I got to be here and see you guys and talk with this kind of broader community that I'm in. So thank you.
No, thank you. That was a great project, great presentation. As I said, I will remind our producer that they need to send you one of these.
Yep.
And you need to send one to Luke as well.
Yep.
Yeah,
Oh,
absolutely.
can I make one more plug? If you're interested in this, I'm recruiting PhD students.
Ooh.
So look me up, email me. I'm open to work with new people, and I'm really excited to work with people who've worked with Arduino before.
Nice. So that we'll send you some goodies, and you also get a T-shirt.
Yeah.
Oh, we have the youngest Arduino user in the not the youngest one. Luke, you have 10 seconds to plug something or to say goodbye to the audience.
Thanks for having me and thanks for watching. Good.
Yeah, so this was totally great. Benedetta, you want to introduce our new co-host?
Oh, yeah, this is the youngest Arduino programmer. Just kidding. Oh, everybody's crashing today. This is what happens when you don't have a nanny. It's bring your kids to work every day.
Nice.
We actually got to hear Luke play before, and he really loved it because I told him that one of the synthesizers is what made the R2D2 sounds.
Yeah.
He's obsessed with. So
You can come over anytime and we'll make some bleepy noises. It's fun. Yeah, absolutely.
Nice. So somebody says that Kayla is creative and Luke is scientific. Okay, that's a comment from the audience.
Both of you.
Yeah.
Anyway, so thank you very much, guys. This was great. You will get a little bit of gadgets and hardware from us as a thank you for being on the show. Benedetta, please don't get more Santan than this because
I can't. I don't think I can. I don't think it's possible.
I'm super pale. You're getting all Santan. I'm getting jealous.
Put on sunscreen, everybody out there.
Right.
It's season to buy sunscreen.
All right. Thank you very much, guys. We're gonna go. We're gonna say goodbye, and we're gonna go offline. I'll see you next week at 9 p.m. European time, 3 p.m. New York time, and work out the math for the rest of the world. Thank you, and good night.
Good night. Thank you.
Broadcast.